Hello, my name is Gentiane Venture, and I'm a professor of robotics in the Faculty of Engineering at the University of Tokyo. I'm also a cross-appointed fellow with the National Institute of Advanced Industrial Science and Technology in Japan. And I'm a roboticist, and my research focuses on the dynamics of human motions, robots, and how they interact with their environment. In my group, I've been working in a very transdisciplinary manner because I don't see robotics just as a field of engineering, but as a field with applications in areas that are rather an art of living together. And in this class that I have entitled Expressive Robot Control, I would like to explore with you the intersection of robotic control and human psychology. So it's going to be a very interdisciplinary class where we will be talking about what we call more often behavioral objects. This is this kind of references that I will be using, where we will be touching about the theory of emotions. How can we make as human expressive motions, and what are the underlying emotions and affects that we are showing through our movements. And for this we will be using books such as The Feeling Body. And we will be also using the expressive motion theory that has been developed for the performing arts, and in particular the Laban notations. And of course we'll try to understand a little bit what are the physiological aspects of emotions, because this is what we're going to be using for understanding but also measuring expressive movements and affects in humans. Then I will try to place an emphasis on the interdisciplinary nature of expressive control, in particular incorporating aspects of control theory and artificial intelligence and computer vision, because what we will be trying to do during that class is to use everything that we could learn from the human and to apply it to a variety of robot structures. For instance, these robots could be mobile platforms that are rolling and moving around in the environment. They could be kind of industrial robot arms that are moving in their own environment as well. Or they could be also robots that are fully anthropomorphic, or they could be robots that have absolutely not the shape of a human, such as, for instance, this small robot here that you can see. This is a mock-up. You can see the real one during the class as well. So this class is not only to focus on the technical proficiency, but also to try to encourage a thoughtful considerations on ethical and societal implications of robotics. Because what we want to do is to understand human expressive behaviors, to recreate expressive behaviors in robots through control, but also to try to understand what does that mean to create expressive robots, and in particular, how is these kind of robots going to change our society, and what are the ethical procedures that we should put in place to actually protect users and when we're running experiments in particular. So in this class you will not only learn how to understand, recognize and classify expressive behavior of humans, but also how to reproduce expressive behaviors in robotic structures. And of course we're not going to be interested only on humanoids or human-like structures, but we will also try to render expressive movements on a variety of robots, such as mobile robots or small robots like this that have very few degrees of freedom. And you're going to see that it's not because they have few degrees of freedom that they cannot be expressive. We will also try to put an emphasis on ethical considerations, because creating robots with expressive behaviors is not something that is completely anodyne. So we have to think about what are the implications when we are creating a robot with expressive behaviors. And also, to evaluate expressive behavior, it's often important to run user experiments where we are inviting participants to go to the lab and see and look at our robots and evaluate them. And in that case, we also have to have some considerations on ethical issues, such as how to pick up participants, what are the implications for them, what are the risks, and we will also address all of these aspects in the class. Finally, all along the class you will have a series of small assignments on the different topics, and at the end you will have a final presentation summarizing everything that you have learned during the class, applying all of the concepts to understand expressive behaviors, to generate expressive behaviors on robots, and also to run human experiments. I hope you will enjoy that class, and I hope to see you soon.